Welcome back, my dear students. In the previous class, we just learned different types of mirrors and also the rules to draw ray diagrams. Now, let's see the formation of image at a different position for a convex mirror. Convex lens, I'm so sorry. It's a convex lens. Let's start with the first situation. In the first situation number 1. So let's say this is a convex lens. Yeah. So let's draw a straight line. It's an imaginary line. That line we'll call it as a principal axis. So let's name them optical center. Let's make it as focus f1 and f2. Sorry, 2f1, f1 and 2f1, f2 and 2f2. Let's say image is object is at somewhere around, which means it is at infinity. So the parallel rays are coming. So when two parallel rays, 2 or 3, anyway, parallel rays comes and hits the convex lens, what happens is after refraction, when a light ray parallel to the principal axis, after refraction, it passes through the focus. Right? So this ray also passes through the focus, and they both meet at one point over here, which means coming to the characteristics of the image that has been formed here. Let's see one by one. Object at infinity, image at f2, size, point size, and the type of image that has been formed here, type of nature of the images, the rays really met with each other. So the type is real. If it is real, always it should be inverted. Clear? So this is first situation. Let's move on to the second situation now. Again, convex lens. f1 to f1. The object is beyond to f1. First situation, laser passes parallel to the principal axis. After it met, it passes through the focus. Second situation, when a light ray passes through the focus, let's say this is focus. After it met, it passes parallel to the principal axis. And let's say this is 2f2. And the object is going to be formed. Sorry, image is going to be formed exactly in between f2 and 2f2. Right? So which means object is it beyond 2f1, beyond 2f1. Image is formed between f2 and 2f2, between f2 and 2f2. What about the size? Size is a little bit small than compared to the original one, which means you could easily write diminished. Diminished means small image. And what about the type of image or nature of the image? Is same just like before, which is nothing but the rays really met, right? So it has been real and it always inverted, real inverted. Right, this is the second situation. Let's move on to third situation now. Third situation, the object has to be come little bit closer to the lens. Optic center f1 and 2f1. Let's say the object is a little bit bigger. Let's decrease the size. Okay, now let's focus f2. When a light ray passes parallel to the principal axis, after refraction, it passes through the focus. Let's say this is focus. When light ray passes exactly through the focus after refraction, they both meet at one point over here, And if you find, and this is 2f2. So object at 2f1, image at 2f2, which means just like the mirror, concave mirror also, if object is at center of curvature, image is also at center of curvature. The characteristics of image formed over there were same, just like here. The size is same size, and the type of image is just like as a real and inverted. So no need to worry about these things now, right? Because you all know all these things. Just only some of the points might get changed. Remaining everything will be same. So next move on to the fourth situation. Coming to the fourth situation, let's say this is convex lens. Let's draw an imaginary line. Let's say f1 and 2f1. The object is in between f1 and 2f1. So the light ray is coming parallel to the principal axis. Okay. After coming parallel to the principal axis, it has to pass through the focus. Okay. So next situation, when a light ray parallel, okay, it passes through the focus. It passes parallel to the, so 2f2, and the image has been formed beyond 2f2. So let's see here. Where is the object here? Object is in between 2f1 and f1. And what about the image? Image is beyond 2f2. What about the size? Coming to the size is little bit magnified, increased a little. So we'll say it is magnified image. And what about the nature of the image? Nature or type of image, which is nothing but real and inverted. Did you get it? Okay. So let's move on to the fifth situation. Coming to the fifth situation, the object is exactly placed at focus f1 and f1. Now the object is at focus. Let's say in the first situation, the light ray passes parallel to the principal axis. So it passes directly through the focus. This is f2. And coming to the next situation, we don't have a choice that it has been have a choice to go to the focus. So we have to pass this through the optic center. So when a light ray passes through the optic center, now it is going to form two parallel lines. Just imagine your head is on the railway track. If you look over the railway track, it looks like it is going to meet at one point somewhere around infinity, maybe, right? So just like the same thing, these two parallel lines also meet at one point over somewhere around infinity, right? Okay, let's see. In the first situation, okay, where is the object now? Object is at focus f1. Image is at infinity, right? This is the first situation that has been reversed. What about the size? Size is magnified. What about the nature of the image or type of image? Here, somewhere around, it is going to be formed, right? So it is real and inverted. Did you get it? Okay. So that's it about the fifth situation. Let's move on to the sixth situation now. So coming to the sixth situation. So this is the convex lens. This is the principal axis. This is the optical center. So the object is in between F1 and O. Okay. In the first situation, the light ray passes parallel to the principal axis. So it has to go to the focus F2. Okay. It passes. It has to pass to the focus F2. And next situation, just like here, the object passes through the optic center. If you observe, these two are not parallel lines now. These two are divergent lines because as the distance increases, the distance between these two lines also gets increased. Which means these two are divergent lines, so these two never get met. So for this purpose, you have to make this reflected ray a little bit backward, extend a little bit backward. So they meet at one point over here, and the image is going to be formed on this side, right? So let's say in the first situation, where is the object? So the object is at F, okay, between F1 and O. So the object is in between F1 and O. And where is the image? So the image is formed same side of the lens. Same side of the lens. What about the size? Size is magnified. And what about the nature of the image? Nature of the image is, it is not real, right? Because the real rays never met here. So we have to extend them backward to meet those rays. So that was nothing but virtual and erect image is formed here. So in only one situation, virtual and erect image is formed. In remaining all the situations, we got only real and inverted images formed. Right? So that's it about the overall ray diagrams. So these ray diagrams are very important, and also I'm going to draw the table now. That table is also most important. Let's see. So we have to mention one by one. Okay, let's say first object position, second image position, third size, fourth nature of the object. Right. So first situation, okay, let's draw the object positions one by one. First situation, object is at infinity, and second situation, you have to bring the object a little bit closer to the lens, so it is beyond 2f1, right? Third situation, object is at 2f1. Fourth situation, object is in between f1 and 2f1. f1 and 2f1. And coming to the fifth situation, it is at f1. And final situation, it is in between f1 and O, right? So first situation, second situation, third, fourth, fifth, and sixth. So let's draw it. When the object is at infinity, the image is formed at focus f2. What about the size? Size is a point size or highly diminished. You may write both, anything. Coming to the nature, it's real and inverted, right? So when the object is beyond 2f1, beyond 2f1, the object is in between f2 and 2f2. If you observe it carefully, this one and this one, right? So they both get interchanges. So the size of the image is again diminished, and nature of the image is same, real and inverted. So when the object is at 2f1, the image is at 2f2. at 2f2, same size, and the nature is real and inverted. Between f1 and 2f1, the object has been formed. Beyond 2f2, same thing here. Beyond 2f2, it is little bit magnified, real and inverted. f2, again infinity. If you observe these points, these two and these five and these five, they both get interchanged. They are highly magnified or highly enlarged, real and inverted. But coming to the last and final situation, and only at this situation, when the object is in between f1 and O, the image is formed at the same side of the object. And what about the size? Size is enlarged or magnified. And here it is not real and inverted, it is virtual and erect image is formed. Virtual and erect image is formed. So this is the most important table for examination. So keep that in mind and read it carefully. So let's see the applications based on the image that has been formed. Let's see. In a projector, right? In a projector, the object is placed between f and 2f, right? So the image that we get is real, enlarged, and inverted image is going to be formed, right? So what about the magnifying glass? In a magnifying glass, object is placed at focus and optical center. So we got a virtual, erect, and enlarged image is formed. So let me ask some questions to end this session. Which lens is used as a magnifying glass? Which lens is used in a magnifying glass? That lens is nothing but a convex lens. Keep that in mind. Do remember it. Where is the image is formed when the object is at 2f1? So at 2f2, what type of image is formed by convex lens when the object is in between f and optical center? The type of image that has been formed is nothing but virtual and erect image is formed, and also enlarged image. Virtual, erect, and enlarged image is formed, right? So that's it. These are all the some important questions that are related to this. And coming to the next session, we are going to start sign conventions and lens formula, magnification, and some important problems based on this. Right? We'll cover it up. Okay, that's it.